Hello, Assalamualaikum and hi. My name is Muhammad Zulmiftah bin Zakaria with the ID number of 18002356 and I'm from Mechanical Engineering Students Group 1. For today, I would like to present my lab report video regarding fluid statics that entitled Buoyancy and Archimedes Principle. So for this lab video presentations, I'm going to present 5 points. Okay, without further ado, let us go straight away to our introductions with being questioned as what is buoyancy and Archimedes principle? Okay, from what I've learned during the fluid mechanics class, it is stated that Archimedes principles states that the buoyant force on the body in a fluid is equal to the weight of the fluid displaced by the body. So for the whole experiments, we are going to discuss and referring all of the principles based on these statements. So moving on to our next point, which is objective and methodology. So for this part, I'm going to explain the goals and the technique that have been used to conduct this experiment. Okay, first of all is the objective for these experiments is to study how the balance of forces between the weight of the objects and the buoyant force on the object that allow the objects to float. And to investigate these relationships, experimental data technique was selected, whereas the data will be collected through active interventions by the researcher to produce and measure change or to create difference when a variable is altered. Okay, moving on to our next point, which is the procedure of the experiments. Okay, for this experiment, we are going to in need of big rotated cylinder and then triple beam balance, metal cylinder, wood cylinder, ruler, meter stick or vernier calipers, ring stand. Okay, here is the buoyancy apparatus setup. So there are two figures which are figure 2 and 3. So figure 2, this is going to be the whole setup for the whole experiments, whereas we are going to use it twice for metal cylinder and also wood cylinder. And then there are figure 3, whereas this figure 3 represents the free body diagrams for the experimental setup that are going to be used for the calculations and the equations explanations. Okay, so for the whole experiment, we are going to conduct it twice using metal cylinder and also wood cylinder. Okay, first of all, the step is going to be verify the Archimedes principle using a graduated cylinder to determine how much water have been displaced when the metal cylinder are submerged inside the water that have been put into the graduated cylinder. Okay, assuming the density of the water to be 1 gram per centimeter cube, we are going to calculate the weight of the water that have been displaced. And then, using the scale, we are going to determine the mass of the metal cylinder and its apparent mass when it is submerged in water. And last but not least, we are going to find the buoyant force that has been supplied by the water and compare it to the weight of the water that has been displaced. And then after that, we are going to use Archimedes principle again to determine the density of the metal cylinder and also the mass of the metal cylinder and also the volume of the metal cylinder. So with the data, we are going to compare the two results and then find the percentage difference. And after that, we are just going to repeat the process using the wood cylinder. And so here is our results and discussions parts for the whole experiment. So here we are going to analyze free body diagram of the systems based on Newton's second law. So here we have three forces, which is tensions, buoyant force, and the weight that are coming from the metal cylinder or the wooden cylinder itself. So the total net forces of these systems are going to be 0. Okay, so here we can see that this is the general equations for the buoyant force. Okay, so here we want to relate why metal and wooden cylinder are having different results when are submerged in the fluids. So for metal, it is going to be submerged, and for wooden cylinder, it is not going to submerge. So here the reason is that, as we can see from the volume force equations, all of these variables are constant, so that we can't say that the reasons they are submerged are due to their own buoyant force. So, but then it is submerged because of their own weight of the metal cylinder itself. As we can see from the equations here, if we put weight equals to tensions plus buoyant force, whereas tensions and buoyant force are constants, the only reasons that we can conclude here is that the reasons the mass the metal cylinder is too high, so that the buoyant force can compensate with that to float. So as the conclusions, it is true an object immersed in a fluid experiences a buoyant force that is equal in magnitude to the force of the gravity on the displaced fluid. So, but then we go back to the goals of the experiments where we have to investigate the relationship between the weight of the object and the buoyancy. Yes, it is relatable if we are going to investigate based on the floatability of the objects because when you are considering only the buoyant force, the weight of the objects are not affecting the buoyant force at all. So that's all from me. Thank you.